All right, so this essential understanding statement at the top basically says that if you want to solve these absolute value equations, or eventually inequalities, as you're going to see later on in the video, the first thing that you do is you isolate the absolute value expression if necessary. This is the absolute value expression, the part that's the bars and everything inside of it, okay? So as you can see here, we have something else going on there, which is this 2 is being added to it. So we need to first isolate this part, okay? Then we can split it up into a pair of linear equations or inequalities. So what does this look like? Well, the first thing that we want to do is we want to say isolate this right here. So we're going to have to undo that. And just to be clear here, how many solutions does this have? We're going to get 2 solutions because absolute value, as we talked about in class, is how far from 0 is a particular number. And you're going to see this when we graph it, because it says here graph it. Okay, so watch what we do here. We have to undo that plus 2 with a minus 2. Once we do that and we get this piece right here simplified so that we've isolated this absolute value part, now we split it apart. We take everything that's inside, in this case just the x, and we set it equal to 7, or we take everything that's inside and set it equal to the opposite, negative 7, okay? Because if there's something extra that you need to solve out, we need to have it split into 2 parts. But this is already finished because it was just x inside. So what does that mean? That means that x is either 7 or negative 7. And here is the idea visually. How far from 0 are each of these points? Here's 1, 2, 3, 4, 5, 6, 7. This is 7 units from 0. And how far is negative 7 from 0? It is 1, 2, 3, 4, 5, 6, 7 units from 0 as well. They both have a distance of 7 units from 0, and that's why we say they have an absolute value. Each of these has an absolute value of 7. So if you plug this in, the absolute value of this, 7, is 7, plus 2 more is 9. Or what's the absolute value of this number right here? If we took the absolute value of negative 7, we would also get 7. Plus 2 is 9. So both of these numbers, when put in here and their absolute values taken, will give us a 7. That when we add 2, we get to 9. Okay? You can check this, like I said, by plugging that number in. Plug in 7. Absolute value of 7 is 7, plus 2 is 9. Absolute value of negative 7 is 7, plus 2 is 9. So they work. Okay? Now, here you try it. Let's see how you do. So, as I said, the absolute value of some variable or number or expression is how far that number, variable, or expression is from 0. So sometimes you get inside the absolute value bars an expression, like 2x minus 5, okay? Now that is 13, whatever this is equal to is 13 units from 0, okay? So as it says, the equation, this means that the distance on the number line from this to 0 is 13 units, okay? So there are 2 points that are 13 units from 0, 13 and negative 13. So if we wanted to find the values of x that would put this equal to 13, meaning 13 units from 0, or to negative 13, 13 units from 0, we set them equal to those numbers and we solve them, okay? So this says here, this key concept, to solve an equation in the form of the absolute value of whatever a is, that can be an expression, right, which is equal to b, where that a represents an expression and b has to be greater than 0, because if it's greater than 0, then what that means is it's a positive number, because you can't have negative absolute values, okay? You solve a equals b and a equals negative b. Set whatever's inside equal to the number that's there on the right and the opposite of it. So if we apply this thinking to this word problem, this is how it goes. Starting from 100 feet away, your friend skates towards you and then passes by you. she skates at a constant speed of 20 feet per second. So her distance is d, and her distance from you after t seconds is given by this. Her distance is equal to the absolute value of 100 minus 20 feet times the number of seconds, okay? At what times is she 40 feet from you? Well, you can imagine that if she's getting 20 feet closer every second, then how many groups of 20 will it take for her to go from 100 to 40? That's one bit of this, okay? And then the next way to think about it is how many seconds will it take her going 20 feet a second to go the entire 100 feet plus another 40 if she's going 20 feet a second, okay? But this is essentially what's going on here. These are the options. So what you do is you say, okay, we are down to just the absolute value bars and there's nothing outside it. So you say, we're going to take what's inside, 100 minus 20c, and set it equal to the number itself, 40, and what's inside equal to the opposite, negative 40, and solve them out separately, okay? Subtract 100 from both sides, divide by negative 20, you get t equals 3. Here, you can do the same thing, subtract 100, now you get negative 140 here, dividing both by negative 20, you get t equals 7. Okay, what does that mean? Well, essentially, if you remember what the question was, the solutions are 3 seconds and 7 seconds. After 3 seconds, she's 40 feet from you and still approaching. And after 7 seconds, she's 40 feet past you after having passed you. Okay, so the correct answer is C, after that many seconds. Oh, and by the way, this says, what must be true of the expression 100 minus 20t? Okay, well, it's got to either equal 40 or negative 40, and that's how we write them. So here's your got it problem. You're going to do the same thing. Imagine this same situation here, okay, with these values so that you can answer what does the 80 in this expression stand for, and what does the 5 in this expression stand for, okay? And then finally, at what times is she 60 feet from you? As I said, an absolute value is always going to be non-negative. Okay, 0 or positive numbers. You can be as close as 0 to something, 0 units away, or you're some positive number of units away from it. So, because it's distance. So any equation that has an absolute value equal to a negative number is going to have no solutions. So what are the solutions of this? Well, notice here, it looks like it says it's a positive number, but we haven't yet dealt with this plus 12 and this times 3. We have to undo those first to get it down just to the absolute value part. And then we can look at what it says that's equal to and then determine. So, by the way, here, oops. How can you make the equation look like one that you've solved before? Well, we're going to use those properties of equality, subtraction property of equality, take away 12, division property of equality, divide by 3, to isolate that absolute value expression. This part that I underlined in pink, that's what we're going to isolate by itself, okay? And then we can then determine what we've got. So if you do this here, you don't see them actually do it. You just see the result, but subtracting 12 from this would make the 12 go away, and subtracting 12 from this would give you the negative 2. Now, if you divided both sides by 3, you get negative 2/3. This is equal to negative 2/3. The absolute value of something is equal to a negative number? I don't think so. And that's the whole bit of this. The absolute value of an expression cannot be negative, so there's no solution. Okay? Try this one. You need to isolate first and then see what you've got. Okay? Up until this point, we've been dealing with absolute value equations where it's equal to something, and therefore we just get two single numbers that are solutions. But right now we're going to be switching to absolute value inequalities, and when we do that, we get ranges of numbers. In fact, we're going to be able to write them as compound inequalities. So here the graph shows, these graphs show two possible ways that you could see it. You could have the absolute value be less than some number, which means this expression, n minus 1, is between 2 and its opposite, negative 2, like this, okay? Because it's less, so it's closer, it's got this little middle in between there, okay? Or you could say that absolute value expression is greater than 2, in which case we still need to solve for what those n values are. But when we're saying things that are greater, we're saying bigger in the positive direction, bigger than in the negative direction than those endpoints, okay? So once the absolute value portion is greater than the number, we're going to be going off into infinity into full, as great as possible, positive and negative. Okay, but if it's less than, it's going to be between them, small little range. Okay, and because of this one, we have to do it in two parts, and this is how it looks. You would say that expression n minus 1 inside is greater than the number there, written like drop the bars and write it the same way, that expression, leave this the same, it's greater than, leave that the same, or you switch both. You say n minus 1 without the bars, switch the direction of the inequality, and also switch the number. So when you make this second time you make that negative, that's the time that you've got to switch it, okay? And we'll work some problems like that. So, and it works also, this is just a note saying what we just said, and also that it works the same for if it said or equal to, okay? If the absolute value is less than this b value, it's going to be between b and the negative of b, okay? But if it's greater than b, it's going to be either fully greater than b or less than the negative of b. And when this video stops right now, this is an excellent time for you to record notes. If you're not writing anything down here, if you're not trying to keep track of it and you're just staring at it and learning it, okay, good luck with that. But you probably should be writing stuff down. All right, what are the solutions of this? Well, there's nothing to do on the outside of it, like simplifying this out before, like you can treat this like a variable, and if there was other things outside the absolute values, you would undo this inequality as though it was just a variable until you get it down to just the absolute value part, which we have. So now we can say, let's split it apart, and we're going to set what's inside greater than or equal to 24, just like it's written, and then we will set what's inside less than or equal to, switching it, and negative 24. Two changes that go together. Either you say what's inside, keep these two the same, or say what's inside, switch this and switch this to its opposite. So take a look at that. Okay, here they have that. So we say, okay, we're either going to write the way that it is, 8n is greater than or equal to 24, just like it is, or you're going to take what was inside, switch the direction of the inequality, and switch the sign to its opposite. Okay, then we solve each one separately, dividing both sides by 8. You get this, n is less than or equal to negative 3. That looks like that. And here you get this. Dividing by 8 is n is greater than or equal to 3, like that. Okay, why is it split up? Well, you can see that the absolute value part is greater than the number, so you're going to get it in two parts. So try this one. Do try this one. All right, here's a word problem involving this, but it's basically what you were doing before. Okay, so a company makes boxes of crackers, and the crackers should weigh this much, the boxes of crackers, 213 grams. And they can never make them perfect, but they can have them within a certain, not too far off of that. That's the idea. So a quality control inspector randomly selects boxes to weigh. Any box that varies from the weight of 213 grams by more than 5 grams has to be sent back. So what's the range of allowable weights? So we say, well, we're talking about the difference between what the box weighs and what it should weigh. And that number is, at most, it's got to be 5. It says if it goes more than 5 grams difference. So it could be 5 grams difference, just not more. Okay. So defining the variable, we say let W equal the actual weight. We know what the ideal weight is, 213, the actual weight of the crackers in grams. And how do we write it? We would say that difference, if we take the difference between the weight and the cracker box ideal weight, okay, it could be positive or -5 depending on whether this was larger or smaller. So that absolute value has to be less than 5 grams, or it could be equal to 5 grams, just not above. So when you do this, then you say, okay, we can see that that value is less, so it's going to be this small range in between, right? And we set each piece, first time we put it here, we say the high end is 5, the low end is -5, because remember we do the opposite over there, and we're always pointing to the greater, so the negative goes here, then this, then the positive goes here. And when we add 213 to both sides, we get this. So what does that mean for us? That means that the weight of a box of crackers must be between 208 grams and 218 grams inclusive. And the word inclusive means it could be that number itself. It doesn't have to be just greater than that or less than that, but it could be those values as well. And it's an or equals situation. Inclusive means include those numbers in the set. Okay, so this is your got it problem. Give it a go. See if you've understood this correctly. All right. These might take a few problems for you to do to really get this conceptually. I'm going to suggest that you, when you do the homework, you have them give me another problem, give you another problem, give you another problem until you get it. And there are also book problems, a whole bunch of them actually. If you look on the resource page, the problems from the section that are assigned, there's a whole bunch of them, and you can see them solved out in the videos. And you should probably watch them until you really get your mind around this, because once you get your mind around it, it's actually fairly doable, challenging but not horrible, but it looks really scary until you get it. So you should spend the time to practice it, and then you'll have a lot of confidence and do really well in the quizzes and tests, or the tests. So good luck.